do a quick poll. So the way you're going to answer the poll is either thumbs down, thumbs up, or anywhere in between. And the question is, do you think the internet is fundamentally good for you? All good, all bad, somewhere in between. Ready? Go. Okay, so it's kind of like there's a spread, but I would say it's kind of around here is the average. And just for the record, before I launch into this and you think I'm a cyber techno-utopian trying to steal your jobs and your money, just for the record, I'm about here, I'm on your side, okay? But I'm biased because the internet has really affected my life profoundly, and I think that the internet's impact on the human race, and really the fundamental requirement that we have to change our cognitive models in order to understand and live in this internet age. I really believe that strongly, so I want to first talk a little bit about that. And so I think of my life in two pieces, and I think of the world in two pieces. The piece before the internet, BI, life was simple. Things were relatively predictable. You could sort of study as a child, become an adult, and then you could just repeat what you learned for the rest of your life, make children, make money, protect things, and that was fine. And you had rules. You had economists that actually predicted things correctly a lot of times. I mean, these were like Newton's laws. You could count on the billiard ball hitting this and this happening this way, and so you could plan things and predict things. But the internet came, and computers got cheaper, and the world changed, and it came and changed into what I call AI, after internet. So after the internet, it turns out these laws that we had were just local ordinances, that they didn't always work anymore. And you have some wonderful books like Black Swan and lots of books talking about how the world has become complex, unpredictable, and every major positive event and negative event that we have today couldn't have been predicted, wasn't predicted, and somehow in this world of chaos and high speed, you've got fluctuation, amplification, and everything from climate change to the financial markets, we don't really know what to do about it. And the thing is that those laws that we had aren't replaced by different laws. They just don't work anymore. And it's kind of like the more you think about it, the more confusing it gets. So I want to talk a little bit about this AI world. Not all of the world has changed into AI, but I think that everything will eventually be AI. And I'm going to start by just using a personal example because I was involved in the first internet service provider in Japan. So this is how traditional innovation works in sort of infrastructural technology. So you have governments and large companies who send experts wearing neckties who have the authority to participate in these intergovernmental agencies like the ITU, which hangs off of the UN. They create these specifications that are massive. They're like meters high. And then no one individual can ever turn these specifications into anything. They have to go with hundreds of millions and billions of dollars into large contractors who then turn these specifications into products and services like our mobile phone networks. And then those get paid in fees and taxes and goes around and around. This takes years. They predict every possible failure, every possible opportunity. It's very controlled, very funded, and very authorized. This is important when you're deploying lots of money and building fundamental infrastructure that we count on to not break. And back in the early days when the internet was being created, these guys were also trying to create a version of the internet. And I was involved much more in what turned out to be the winning thing, which was we had the internet, we had governments involved, we had small pieces of the government, we had students, we had big companies, small companies, we had teenagers. They were all connected to each other, creating open source software. And the credo of the internet was not you have to have permission. It was this permissionless innovation, and the credo was rough consensus running code. Let's kind of figure out what we're doing, but let's just build it. Versus let's figure out every possible thing that could go wrong, specify for it, and then build it, and then test it, and then run it. So it's very, very different. One is big money, big research, centrally controlled, versus chaotic, almost anarchy, completely distributed innovation without permission, to the point where I had lawyers in Japan writing me letters saying, this is completely illegal what you're trying to do. You have people connected to each other without bilateral agreements. Who's going to take the risk? You just can't do this. It's not illegal. So too bad. We made it. And so what happened was the internet won. Okay? And it wasn't that a technology won. It was a fundamental philosophy that won, and the philosophy was build first, think later to some extent. It was permissionless, it was distributed. David Weinberger uses the term small pieces loosely joined. All the critical pieces of the internet, most of them were created by small groups of 2 or 3 people. The web, the DNS, all these components, most of them was built on free software. It was a completely different model of innovation. And so I kind of generalized that theory, but first of all, this is a picture of my toilet, or actually my toilet's over here, that's my bath, in the early 90s. This is the first commercial internet service provider in Japan. And if you look at that VT100, only half the screen worked, so you can only see 40 characters. All the stuff was so broken, the Cisco AGS ran so hot that we had to, anyway. But for thousands of dollars, we were able to make the first point of presence to the internet in Japan. And if this was done by a telephone company, it would have cost millions of dollars. And because it had all these specifications and all these rules, well, we just slapped it together because as long as you met the basic requirements, and it sometimes failed. You know, we had it overheat, and we had to sit there blowing on the hard disk until the new fan arrived. But considering it was 1/1000th of the price, that was pretty good. And so suddenly, with these little kind of scrappy internet startups, it forced competition where there wasn't competition, and the cost of communicating, the cost of distribution, the cost of collaboration went from infinity, in that students couldn't afford it, to nearly zero. You could afford it. If you were at a university, it was nearly free. So that was a big deal, because then what you could do is you could build on top of it. So if it weren't for the internet, we wouldn't have Linux and Wikipedia and all these other things, because those happen because people can contribute, because it doesn't cost them anything to connect. If it cost you $10,000 a month to contribute to Wikipedia, you wouldn't do it. And so if you take that, and then you add Moore's Law, which I'm not going to insult you by explaining too much, but everybody knows, Moore's Law is the rule that computing power basically doubles every 18 months or so. So the cost of computing has gone down. So in your iPhone, you have more computing power than the first Apollo launch. So if you add to the fact that the computing power has gone down, so anybody can afford a computer, not anybody, but most people can afford a computer, and that the communication costs have gone down, so distribution, collaboration, communication has gone down, the cost of innovation has gone down. And to explain a little bit about what that means, in the old days, BI, I remember these days, when you tried to build like Minitel or the reservation system for Hertz Rent-A-Car, it costs millions and millions of dollars, sometimes billions of dollars to build these things because you're building them from scratch. So what you would do is you'd have somebody, I'm sorry, I'm not partial to neckties, somebody wearing a necktie, writing a business plan, trying to raise millions and millions of dollars from somebody who has a lot of money. And then once you got the money for the business plan, then you'd hire the engineers and you build the thing and you deploy it. That was how technology was deployed in the old days. Today, what happens? Well, a couple of students build it first, because it doesn't cost anything to build a Google or Yahoo or Facebook, just some ramen and some time. And then Google, for instance, raised, I think, $50 million before they had a real business model. So you build the thing, raise the money, then come up with the idea. So it's kind of another way of saying it. It used to be MBA first, engineer last. Now it's engineer first, and maybe MBA last. Now, nothing against MBAs, but I think you need them at a different phase. And it's not for all industries. So it's basically consumer internet and software. It has completely pivoted, because what happens when you lower the cost of innovation, you don't need permission, you don't need money, and so it doesn't happen. That's why I'm from Boston. You know, there's this whole Annalise Saxenian's book about regional advantage, about how the innovation left the big companies. You don't have the DEX and the Amdals anymore. It moved to the West Coast because that was where the agile, scrappy, permissionless innovation was going on, and it wasn't happening in the big research labs. So that's a general trend of like the centrally controlled, power-based innovation went and changed to this innovation on the edges. That changes the nature of risk. So now that I'm somewhat sort of an academic, I worry about the fact that this really doesn't have any scientific or mathematical relevance. So ignore the axes. But this is kind of what the brain of a big organization person looks like. So if you talk to the CEO of a big company and you ask them, well, how much time do you spend worrying about how much money you're going to make? Well, we can grow our market share here, cut margin there, but I'm mostly worried about losing money, about market failure, about the fact that I take a $10 million job and it costs me $100 million to deliver it. I worry all day about downside risk. If you look at it, so I used to be a venture investor until I started the Media Lab. My average investment's $100,000. So guess what? My downside risk on every deal is $100,000. So I don't worry about my downside. If I bet money on somebody and they fail, I look at it, try to figure out what I learned, maybe have them work on another deal. But the main thing I'm looking for are the deals that pop up. I've been lucky to invest in nice companies like Twitter. I'm not going to boast about them, but I guess I will. Twitter, Kickstarter, Flickr, Last.fm, and you don't get many of them. I've invested in hundreds of deals, and every once in a while you get a pop. But those pops are the ones that you double down on, and that's what you focus on, is the upside. You do focus on the downside to the extent that they are information. They are where you find your great people to then pile into the upside ones. But you don't throw them against the wall and say, hey, give me my money back. And then when they're running out of money, you don't spend all your time trying to help them. What you do is you try really hard to get better at being invited to the party when they're raising the money for the big ones. This is a very, very different kind of thing, because if you think about this inside of your own organization, there are probably people here from big companies. Imagine Jimmy Wales comes to you and says, I'm going to build an encyclopedia, and it's going to be one of the biggest sites on the internet. And the trick is, anyone can edit it. You wouldn't even give the kid a desk, right? It's a stupid idea. But the thing is that he didn't have to ask permission. He just built it. They built it. And then it was a success. Now, it turns out there are a bunch of other Wikipedia-like projects at the time that failed. Who knows? Who knew? I don't know. They didn't know. It's the same thing with Linux. I mean, if you read Linus Torvalds' original message to Usenet, he's like, I don't know if this is going to be a big deal. We're going to do this thing. If you want to hang out, let's hang out. And then it goes. The trick is not to always be right. The trick is to make sure that you're there when it happens, and to make sure that you're not holding these people back by requiring permission. And it's about permissionless innovation. Because the cost of sitting around trying to decide whether you should give this person permission exceeds often the cost of trying it. I had a company that was trying to raise money, $600,000, a lot of money back at the time, and the company spent $3 million on their feasibility study to decide not to invest $600,000. If it costs more to decide whether to invest than the investment itself, maybe you should just invest. Okay. Next slide. Let's see. So another really important thing is agility. Because the world is changing so fast. In this chaotic world, agility is really important. This is one of my favorite slides. If you go to archive.org, you can see this. This is YouTube, 2005. So if you were using YouTube back in 2005, you would have the default option, I am male, seeking everyone between 18 and 45, upload video. YouTube was a dating site with video when it started. Okay? And Chad is a little bit embarrassed about this. We've talked about it. But it didn't work very well, so they pivoted. And they changed it to, when I met them, they were doing Flickr for video. And I should have invested then, but I didn't think it was a good idea. And then they saw MySpace going like crazy. They saw that Google had this thing with MySpace. MySpace, they didn't want to work with MySpace. So they jumped onto MySpace, said, we're going to be the video embed for MySpace. And they latched on and went for the ride. And then they skyrocketed. And even though their technology wasn't as good, I didn't think, Google had to buy them. And I talked to Chad. He said, yeah, no, we knew that our trajectory was video. We wanted to be the biggest video site in the world. And we weren't really obsessed with the dating site thing, but we started with that. But now imagine if you were a big company that had patents and people and spent years building this dating site. They would have said, yeah, we should try a little bit longer. Maybe try a little bit longer. Maybe we should do a study. You know, and it would just sit there. And the thing is, if you think about it, all those things on the balance sheet of a big company, lines of code, intellectual property, people, brand, well, when you think about it from the perspective of agility, those are liability. Those are like weights. And now when you look at companies like Facebook and Google, they do everything in their power to remain agile, because that's their competitive edge, because the world changes, and if you've got a 5-year roadmap that you can't change, you're dead, right? And that's true in software. It's starting to be true in a lot of other things. The other really important thing is serendipity. So most of the best things that have ever happened in my life, like meeting Shaka and all these things, is because of serendipity. And just a fundamental truth, if you plan everything, you can't get lucky, right? Sort of. So there's this interesting study that I like to cite, which is that they picked all the lucky people in the world. They did a study where they invited all the lucky people and all the unlucky people and invited them in to do a study. They gave them a newspaper and said, count the photos in the newspaper. And what they did was they were 45 photos in the newspaper, and there's a headline that said there are 45 pictures in this newspaper. And another headline, big one, said $250 if you see this headline. So all the lucky people go, 45 photos, give me $250. And all the unlucky people sit there and counted everything, right? And serendipity is about having peripheral vision. It's also about having this kind of pattern recognition. But one other phrase I want to add on to this sort of post-internet thinking is John C. Brown and John Hagel have this book and this word called the power of pull. And I'm going to give you an example of what that means. It really means pulling from the network as you need it, rather than stocking stuff in your head, whether it's programming languages or money. So when the earthquake happened, I was in Boston interviewing for my Media Lab job. And I was panicked because I wanted to get a Geiger counter for my wife. So I started calling my friends, Skyping them and connecting, and within a week I had Ray Ozzie, the guy who did the 3 Mile Island monitoring system, and a whole bunch of people. And within a week I went from knowing nothing to knowing how to get Geiger counters, how to build them. And then within a month or so we had a pretty broad network of people who could visualize it, people who could make web apps, and we sort of glommed on anybody else in the space. And then what we realized was there weren't enough sensors, so we put them on cars and we drove them around. This was Ray Ozzie's idea, which was great. And we started collecting tons of data. And we ended up in these neighborhoods where you had the government having gone in with hazmat suits and walked away without giving the people data. And then we have these funny foreigners in T-shirts coming in, teaching these people how to decontaminate. And they said, well, we usually don't like foreigners, but we're going to make a nonprofit. And if something like this happens somewhere else in the world, we're going to go and say, we're from Fukushima, we're here to help. And it was this really interesting sort of citizen science moment. But the Media Lab kids sort of started working on visualizing the data. We now have over 9 million open data radiation measurements. The Japanese government, I think, probably has around 20,000 or so, and they're closed. And it's become, now we're doing pollution sensing in LA and stuff like that. And then it turns out Geiger counters don't get innovated on, so we created our own Geiger counter, and it's open hardware. But my point here is that if we had sat there and planned everything, like the government did, it wouldn't have helped. And even though we started the day after or day of the earthquake, we were able to assemble the team together to build this amazing network. Now think about what we're teaching our kids. Okay, you're going to be on top of a mountain with no friends and no internet and number 2 pencil. What's the answer, right? We're not teaching our kids to do this, to pull from the network as you need it. We're not teaching our companies to do this. We're investing in things like R&D in the middle of the company instead of working on the edges. The other thing about this device is it's open hardware, so you can download it and make it yourself. And then this is where the last pivot I'll say is that stuff about software getting cheap to make, it's happening with hardware, 3D printers, laser cutters, agile manufacturing. This is one of our students. I'm an investor in this company. It's a 3D printer. The cost of innovation for hardware is going down. Hardware ventures are going to explode. And that roadmap, that agility that we need for software is going to happen for hardware. This is the DuPont gene microbe that converts sugar into polyester that shut down the fossil fuel polyester manufacturing because it's so much more efficient. This is expensive to design. Now at the Media Lab, we're working on gene fabrication, so you can print genes at scale and at high complexity. This is going to happen in biology really, really soon now as well. So biotech, hardware, everything around you is going to start being impacted by lowering the cost of innovation, which pushes the power to the edges and will fundamentally change things. This is our lab. And at our lab, everybody piles on top of each other, and we just build things. And the key to this is we call it AntiDisciplinary. If you could do whatever you want to do in some discipline anywhere else in the world, you don't belong at the Media Lab. Only come to the Media Lab if you are outside of a discipline and can't do what you want to do anywhere else. And we have what we call undirected research, which is we do very few grants, we don't tell our people what to do, and we're trying to explore the white space between the disciplines. You don't want everybody in the world doing that, but it's kind of like pattern recognition. So I'll leave you with this. These are my principles. It's really about don't try to resist failure, be resilient to it. Pull instead of push. Don't focus on trying to be safe. Be smart about how you take risk. Practice over theory. Don't wait for the theory. Build first. Come up with theories later. Compasses, trajectory is more important than the map, which is often wrong and really expensive. Don't think about the particular object thing. These are kind of obvious things. Disobedience over compliance. You don't win Nobel Prizes for doing what you're told. Question authority and think for yourself. Emergence over authority. And learning over education. Education is something that people do to you. Learning is what you do to yourself. You need to teach your kids and yourself how to learn and how to be passionate about learning. And I love education reform. It's really important. But we focus way too much, I think, on this kind of method of delivery of knowledge rather than how do you get people to be able to build things like that safe cast story I told you. Thank you very much.